In preparation for your Chapter 3 test in Algebra 2, we're going to review systems of linear equations and inequalities and solving them. First, let's review how any two lines can relate to each other in the same plane. Now we have to make sure we're in the same plane and not up in space. So it's like taking two strands of spaghetti and putting them on your desktop and deciding how they can relate to each other. The first way is they can be parallel, or they can intersect in one point, or they can be the same line. So when we're solving these systems and we get to our final answer, we have to look at the final answer and decide which one of these three categories it fits into. Parallel means that the lines do not intersect, so it's safe to assume that there's not going to be any solution. Let's give an example here. If I have 3x plus 2y equals 6 and minus 3x minus 2y equals 8, and I want to solve this by elimination, and I see that I have a hero 0 there at 3x and minus 3x, and just to remind you, a hero 0 are two numbers when added together create a 0. But what happens in this case is both of them on the left-hand side, both the x's and the y's go away, and I have 0 on my left-hand side and 14 on my right-hand side. Excuse me. And you can tell that 0 is not equal to 14. That's a false statement. So if it's a false statement, what that means is there is no solution. The lines are parallel, and that should make sense. No solution, false statement, parallel lines. Okay, intersecting. This is a very simple example, and my hero 0 is with my x's, so I'm going to eliminate those, and I'll have 3y equals 9, which means y equals 3. And if I substitute back into either one of those top equations, I can find out that x plus 3 equals 3 or x equals 0. And yes, 0 is a legitimate answer because 0 is a number. So these two lines intersect at the point 0, 3. They have exactly one point in common. Same line. One unique point. There we go. Forgot about that one. Okay. X plus y equals 6 and minus 2x minus 2y equals negative 12. Let's say I want to eliminate the x's, so I'm going to multiply the top equation by 2, and I'll have 2x plus 2y equals 12, and then copy down my bottom equation, minus 2x minus 2y equals minus 12, and when I add these two together I get 0 equals 0. Well, 0 equals 0 is a true statement, but we don't have any x's or y's left over. So what we know about this is, because it's a true statement, any x and y will fit into that. Choose an x and find a y, and both of those will be on that same line, because it's just two equations for the same line. Okay, so let's solve this algebraically. X minus 2y equals 3 and 3x plus y equals negative 5. We could eliminate the x's by multiplying the top equation by negative 3, or we can eliminate the y's by multiplying the bottom equation by 2. It's your choice, whichever one you want to go after. It doesn't make any difference as long as you don't make any arithmetic mistakes. You will come up with the same answer. So let's rewrite this. X minus 2y equals 3. And when I multiply the second equation through by 2, I get 6x plus 2y equals negative 10. And there is my hero 0 right there. My y's go away. So I have x plus 6x is 7x equals negative 7, or x equals negative 1. And when I plug that negative 1 back into either one of my original equations, I get minus 1 minus 2y equals 3, or minus 2y equals 3 plus 1 is 4, or y equals negative 2. So this has one unique answer. These two lines intersect at one point, and that point is minus 1 minus 2. Okay. Let's solve some system inequalities by graphing. All right, here's my two equations. Y is less than 2x minus 4, and negative x minus 2y is less than or equal to minus 2. Okay, so I have my graph here, and I'm going to go after my first inequality, and that's a pretty simple one because it's in slope-intercept form already. So I know that my slope is 2, and my y-intercept is negative 4. So I'm going to start with my negative 4, and go up 2 over 2, up 2 over 2, and then connect it with a dotted line because it is just a less than. All right? And as far as shading goes, it's because it is less than, I'm going to shade below the line. My next one I have to get into, I'm going to choose to get it into slope-intercept form. So that means that I first add x to both sides. So I have minus 2y is less than or equal to x minus 2. Now when I divide both sides by negative 2, I have to remember that I have to flip my inequality sign around. So I'll have y is greater than or equal to negative 1/2 x plus 1. When I graph that, there's my y-intercept, and then I'm going to go down 1 over 2, down 1 over 2. I'm going to connect with a solid line because I have an equal sign there, and then I am going to shade above. So my final solution area is this dotted line, that solid line, and everything that where the green and the yellow overlap each other. Okay, have a good evening, everybody. Get ready for the test. See you in class.